Good day, grade 12 learners. Welcome to today's mathematical literacy lesson. My name is Dikululi Wechuma. This lesson is brought to you by the Northern Cape Department of Education in collaboration with Palama Research and Development. Right, our topic for today will be on measurements, and this topic weighs about 20 plus or minus 5% of your examination. Of particular interest will be the subtopic on perimeter, area, and volume. Right, let's look at what you're expected by the end of the lesson. So at the end of the lesson, you should be able to calculate perimeter, area, and volume of an object. You should be able to change the subject of a formula and correctly substitute values into a formula. You should also be able to determine or calculate appropriate quantities of materials or components required to complete a task. And this information, we obtain it from our CAPS document from page 63 to page 67. Right, what is it that you are supposed to have? The knowledge that you're supposed to have before we start this lesson. From your previous grades, you should have been able to know how to calculate volume of various shapes. You should also have the knowledge of how to pack or stack things in spaces and or containers. You should also have a prior knowledge of three-dimensional figures, especially the identification of length, width, and height, and be able to round off or find ratios between radius and diameter. You should also have calculator skills and logical reasoning that are knowledge and skills that come in handy for this topic. And you should also have the knowledge that contains a strong practical component. Right, from the prior knowledge of area, volume, and perimeter, let's attempt to answer these questions. I'll just give you 5 minutes to complete this task. Right, learners, I'm sure you were able to tackle that with ease. Let's look at the first question. We are given a diagram of an irregular shape, and we are asked to calculate the perimeter of the shape and also calculate the area of the shape. Let's look at the perimeter. How did you calculate the perimeter? We all know that perimeter is the distance right round a shape. So we want to know the distance from this point. We go through up to here, 10 to the right, go down, 10 to the left, take this portion as well, and this portion until we get back to where we started from. So this is the perimeter of this shape. Right. We have 16, we have 9, we have 6,8, we have 5,5. So for us to obtain this part here, since we have 6,8 from here to here there and 6,8 from there to there, and we know that from here to here it's 16. So what it means is, in order for us to obtain the length of this portion, from 16 we have to subtract 6,8 and 6,8. What will that give us? From your calculator, this will be 16 minus 13,6, giving you 2,4. Right. So the perimeter for our shape will be this 16, this 9, this 6,8, this 5,5, and this 2,4. This is the 2,4 that we calculated here, and 5,5, which is this point to here, another 6,8, and another 9. And what is the total distance right around the shape? It's 61 centimeters. That was the perimeter of the shape. What about the area? How do we find the area of this irregular shape? We divide our shape into regular shapes. So we can have 1, 2, 3 regular rectangles. So the area of A plus the area of B plus the area of rectangle C will give us the total area of the shape. So what is the area of A? This will be 16. And the width, how do we find the width? The width will be 9 centimeters minus the 5,5. This will give us the width for A. For B, our length will be 6,8. Our width will be 5,5. Same with C. This is our length. This is our breadth. So we add the area of all those 3 triangles. So the area of A, we have it there with 16 times 3,5. The area of B is 6,8 times 5,5. The area of rectangle C is 6,8 and 5,5. Altogether, it gives us 130,8 square centimeters. Take note of that, learners. Area is measured in square units because we are multiplying 2 dimensions. Right, let's move on to today's lesson. We'll start with the terminology. What is perimeter? Perimeter of a circle is called the circumference. Remember, perimeter is the distance right round the shape. So if I have got a circle, the distance right round the circle is the circumference. So this is the perimeter of a circle. It's circumference. Perimeter is measured in single units, namely your meters, your centimeters, your millimeters, etc., etc. Those are single units. Length means measurement between 2 points on a straight line. So length is always between 2 points on a straight line. If it's not straight, then it's not length. It becomes distance. Circumference is the distance around a circle, just like what I was saying. Now, because this is not straight, it becomes a distance. Radius is half of the diameter. Diameter is a straight line that divides the circle into 2 parts. So from here, if I move from the circumference, pass through the center to the other side of the circumference, this gives me the diameter. So the diameter divides the circle into 2 parts. And half the diameter gives me the radius. So the radius is half the diameter. Then we come to area. Area is the amount of space occupied by a 2-dimensional figure. You know, 2-dimensional figure has 2 dimensions, your length and your width. That's a 2-dimensional figure. So area is measured in square units because we are multiplying 2 units. So we have your square meters, your square centimeters, etc. Surface area is the total sum of the external areas of all the exposed surfaces of a 3-dimensional object. And it's also expressed in square millimeters, square centimeters, and square meters. And volume is the amount of space occupied by a three-dimensional object, usually expressed in cubic units, your cubic centimeters, your cubic meters. Capacity is the amount of space inside a 3D object, and it's usually expressed in terms of milliliters, liters, and kiloliters. Well, capacity usually has to do with the measurement of liquid. Right, let's look at the perimeter. How do we calculate perimeter of basic shapes? We all know our basic shapes from early primary school years. We have the triangle. It has three sides. So what is the perimeter? The perimeter will be side A plus side B plus side C. This is the distance around the triangle. We come to the square. Square is 4 times side. Why 4 times side? Because this side is equal to this side, which is equal to this side and equal to this side. So 4 equal sides will give us 4 times a side. The perimeter of a rectangle. A rectangle has got the length and the width. And we know that this length is equal to this one, which is opposite the other side, and the width is also equal to the width on the opposite side. So the perimeter of a rectangle will be length plus breadth plus length plus breadth or plus width. So your length plus length, if we're grouping like terms, plus breadth is equal to the 2 length plus the 2 breadth. Taking out the common factor, we will have 2 length plus your breadth. So 2 the length plus the width. So this is what we get. Your length plus the width. Then the radius. The radius of the circle helps us to calculate the circumference. Because remember, this distance is not a straight line, but we need dimensions that are in a straight line. So we use the radius, which is a straight line. And there is a special constant that is used to multiply your radius to get the distance right round a circle. So the perimeter of a circle is 2 times this constant, the special constant pi, times the radius. Others may say the perimeter is pi times diameter. Why? Because diameter is equals to 2 times the radius. So that's it on the perimeter. Let's move on to the area. The area of the basic shapes. Again, we have our 4 basic shapes that we've learned about since our primary school days. Perimeter of the triangle. It's half the base times your perpendicular height. Not, it should be the perpendicular height. I cannot take this side and say it is my height. The height is the perpendicular distance. So your height is the distance that is perpendicular to the base. Then the area of the square is side by side. So since the sides are equal, so it is side squared. Then we come to the area of the rectangle. We have the length multiplied by the width. For the circle, again we use our radius because this is what gives us the straight line. Our radius multiplied twice times the constant pi. This pi times radius times radius gives us the formula for the area of a circle. Right, let's attempt this question. Now that we know that the radius gives us half the diameter, can we attempt this? If half of radius is 11 centimeters, if half the radius, not the radius, half of it is 11 centimeters, what is the diameter? How are we going to attempt that class? Okay, we are given if half the radius is 11 centimeters. So what it means is we can write our formula as half of radius is equal to 11. This statement is the same as this one. Half of r is equal to 11. And in mathematics, we know that of means multiplication. So this is half times radius equals to 11. Now making radius for r the subject, how do we do that? We use the inverse of half. So we multiply by this inverse. Then it becomes r equals to 11 times 2. What is 11 times 2? Our radius is 22. But the question is asking for the diameter. We have said that diameter gives us, the radius gives us half the diameter. So meaning the diameter gives us 2 radius. Because from here to here, it's a radius. From here to there, it's a radius. So a diameter gives us 2 radius. So a diameter is equals to 2r. So to get 2r, we have our 22 there, which we got here. Then 2 times 22 results to 44. So the diameter will be 44 centimeters. So the formula for the perimeter of a circle, we've mentioned that one, is 2 pi r. That is the perimeter of a circle, and for the area, it's pi r squared. Now let's move on to the surface area. Remember, surface area is for 3D objects, such that when we open this object, we will have different faces giving us different surface area. For example, a cube. How many faces does a cube have? A cube has 6 faces. As you can see, we have this red part. This red part has a bottom or the base that is equal to it. And the blue part, it has a face opposite it with the same dimension. And the white part also has another face opposite it with the same dimension. So a cube has 6 faces, and all the faces are squared. They are squares. So since we have 6 faces, and the area of a face is side times side. Remember, we said the area of a square is side times side. So the total surface area of a cube will be 6 faces times side times side. If you are to open this box, you will have something like this. So these will be the faces of your cube. Then the volume. The volume is side by side by side. This is its length, this is its width, this is its height. So the 3 dimensions are of equal length. Therefore, we say side by side. That's the volume of a cube. Now let's move to the volume of a rectangular prism. A rectangular prism also has got 6 faces. We have a face that takes the length and the height. This is our length and this is our height. We have this face which has got an equal and opposite face. So they are the two of them. These faces, they are length times height. There are two of them. We also have a face that has length times width. Which one has length times width? This face, it has length times width. This one, which shows us the bottom or the base of the rectangular prism. And this face also has an opposite face similar to it, which also is length times width. This one is at the top. So there are two of them that are length times width. Then we also have another face, which is height times width. This is the face here, which is height times width. So this face has also an opposite face like it, which is height times width. So the total surface area will be having 6 faces, but they are of different dimensions. So 2 of them have the same dimensions, and we add the total areas of those rectangles, and we get the total surface area of a rectangular prism. What about volume? Volume, it will be the length, the width, times the height. It gives us the volume of our rectangular prism. We move to the cylinder. You know the cylinder is made up of the circles at the bottom and at the top. And then we have the curved surface. So for the faces at the top and at the bottom, there are circles in nature. And what is the area of a circle? The area of a circle is pi times radius times radian. And we have 2 circles, the one at the bottom and the one at the top. So we multiply these by 2. What about the curved surface area? The curved surface area, it is the height times the circumference. So we know that for us to get the circumference, it's 2 pi r, because circumference is equal to the perimeter of the circle. So it's 2 pi r. And to get this length is the height, which is our h. So the total surface area of the cylinder is the area of 2 circular faces and 1 curved face. Then the volume is pi times radius times height. What about a triangular prism? A triangular prism has got 5 faces. As you can see, we have this face here that is triangular in nature. And this face has a twin, which is similar to it. So this twin and this one, they are triangles. And what is the area of a triangle? Area of a triangle is half the base times height. But there are 2 of them. So when we multiply by 2, this translates to 2 goes here once, 2 goes here once. We remain with base times height. So the 2 faces, the 2 triangular faces, give us the area of base times height. Then we have these rectangular faces. This one gives us the length and the side, the slanting side. So these 2 are rectangular in nature. They give us the length times the side. So the length times the side times 2, because there are 2 of them. Then we have the base the base of the triangular prism. The base of the triangular prism is rectangular in nature. So we are multiplying the length times the base. This is the formula. So in total, the total surface area of our triangular prism is base times height plus 2 times length times side plus length times breadth, base. And our volume, the volume is half the base times height times length. That is the volume of the triangular prism. Volume can also be said to be the area of the triangle times its height. So we will take this as the height. We'll take the area of the rectangle, which is half base, times height, times this length, which is given as the height. Right? So the tips in calculating perimeter, area, and volume. Always make sure that your units of measurement are same before you can do any substitution. If you have centimeters and millimeters, make sure you're using the same unit. You cannot multiply centimeters and millimeters. It will mess up your calculation. Change the diameter to radius before doing any calculation by dividing by 2. Because most of our formulas, they have radius. So for you to be able to substitute in a manner that will not confuse you, make sure you change whatever is given as a diameter to a radius. Use the value of pi the way it is given, and it is usually given as pi being equal to 3,142. Then when dealing with the semicircle, remember to divide the formula by 2. It's a semicircle, it's half of the circle, so you have to divide the formula of the circle by 2. Whether you're finding perimeter or you're finding area, make sure you're dividing by 2 because it's a semicircle. Right, then we move on to some activities. Now that we know the formulas to use to calculate different measurements, we have a typical examination question obtained from May-June National Certificate Examination 2024. The diagram shows a rectangular compost box linking sections A, B, and C with common panel boards. Calculate the perimeter of the base of the compost box. We want to calculate the perimeter. Remember we said perimeter is the distance around a shape. So we want to calculate this distance at the bottom, the base of the compost box. So the compost box has got how many sections? 1, 2, 3. So our length will be these 3 added together. Then this will be our width. So how do we find the length? Since the perimeter of the rectangle is 2 times length plus width, we have to find the length by adding these 3. And this 3 will give us a length of 6,9 because we're adding this 2,3 plus 2,3 plus 2,3. Then we'll get a length of 6,9. Our width is this dimension here, 3 meters. Then we substitute into our formula. So substituting into our formula, we have our length as 6,9 and our width is 3. All in all, after punching in the calculator, we get 19,8 meters. So the perimeter of the base of the compost box will be 19,8 meters. Right, we move to the next question. Calculate the volume of section A. Note, they are saying section A, not the whole compost box. Only section A. So this is our section A. This part here, our section A. We have the length, we have the width, and we have the height. So we can find our volume. So the volume, we first write our formula. Always make it a point to write down the formula first. Once you do that, it will be easy for you to identify which dimensions are required, and it will be easy for you to substitute. So what is the length of this rectangular box, the rectangular prism? The length, this is the longer side. It's what? 3 meters. What is the width? This is the shorter side. The width is 2,3. What is the height? This is the height for section A box. So from here to here, it's 0,5 meters. Then you substitute into your formula, your length, your width, and your height. Punch it on your calculator. You should be able to get 3,45 cubic meters, because this is volume. It's in cubic units. And take note, all my units were in meters. My 3 is in meters. My 2,3 is also in meters. My height, 0,5, is in meters. And then I obtain my answer in cubic meters. There we go. Another question. The athletics track below is made of a rectangle in the middle of 2 semicircles. We have a rectangle, we have 2 semicircles. Take note of that. With the radius of 36,5 meters at the end. The length of the rectangle is 84,39. So this is the length of the rectangle. The width we can obtain. I'm sure we can obtain. We are all able to obtain that. This is a semicircle. This is a semicircle. So since this is a semicircle, this gives us the radius. Same here. This is the radius. Now that we have the radius, we know that this becomes the diameter. Let's answer the questions then. Calculate the perimeter in meters of the rectangular area in the middle of the athletic track. So we want the perimeter in this rectangular side of the field. What do we need? Perimeter is calculated length plus width times 2. We have the length. What is the width? What is the width, class? Given this as the radius, what is the width? So our width will be equals to the diameter of the semicircle. This diameter will give us the width. So how are we going to obtain the width? The width will be, since diameter is 2 times radius, 2 times the radius will be 2 times 36,5, giving us 73 meters. So this is the width. Now that we have the width, we write down our formula for the perimeter of the rectangle. The perimeter of a rectangle is given by 2 times length plus width. Now we can substitute. We now have all the dimensions. So for our length, we put the 84,39. For our width, we put the 73 meters. And what do we get? 314,78 meters. That is the perimeter in meters. Let's move on to the next question. The groundskeeper stated that the cutting cost for the grass, which covers the entire area on the inside of the track, is 11,900 rands. The inside the track, right? Show by means of calculation whether the cost per meter squared is more than R1.20 per square meter. You may use the following formula. We've been given the area of a circle, it's pi times radius, and we are using pi as 3,142. And the area of a rectangle is length times width. So, class, what do we have to do first? We have to find the whole area of this inner field. And this inner field has got a semicircle and a semicircle and a rectangle. So what it means is our area for the field will be the area of 2 semicircles plus the area of a rectangle. So in order for us to get the area of this whole field, we have to find the area of the 2 semicircles. This one on our left and the one on our right. And then rectangle. Right, let's move. So using pi as 3,4. The area of a semicircle. Remember, the area of a circle is 2 pi r squared. So for a semicircle, we divide by 2. So this is the half of it. So half times pi times radius times radius. But since there are 2 of them, we also multiply everything by 2. Then for our rectangle, it's length times width. Now substituting, we have 2 semicircles. And the area of a semicircle will be half times pi times radius. This is our radius, our 36,5 times 36,5 plus the length of the rectangle times the width of the rectangle. The total area of this inner field becomes 10,346,40 square meters. Now remember, we want to find the cost of cutting the grass inside this field. And we have said this field has this area. So given that it costs 11,900 rands, what will be the cost per square meter? What will be the cost per square meter? So the cost per square meter will be given by the cost of the whole field divided by the area. And what do we get per square meter? That will be R1.15 per square meter. Now, we have shown by calculation that this is not more than 120. We can safely answer and say, therefore, the cost is not more than R1.20. Because from our calculation, we obtained R1.15. Then the athletics club manager wants to erect a fence 5 meters away from the track on the outside perimeter of the outer lane. Note the outer radius that is ending at the outer lane is 46,26. So meaning from this point to the outer lane, it is 46,26. The salesperson from Bright Hardware Store stated that the required length of the fencing needed will be more than 490 meters. Verify using calculations if he is correct. Remember the perimeter fence, the fence that will be outside the track. It will be 5 meters away. To be 5 meters away. So meaning from here to here, we have our 46,26 plus these 5 meters. So meaning the radius will get up to 46,26 plus 5, which will be 51,26. Now this will be the radius for the fence that will go around the track. And the rectangular side will remain as the rectangular side. The dimension won't change because it's still from the same point, to the same point. What has changed is the circumference. So length of the fence that will be needed, we will have the perimeter of the 2 semicircles. So we'll have this one that has been added by 5 and by 46,26 and this 5. And the length, we'll have this length from here to here and the length from there to there. So what will be the perimeter of the 2 semicircles? Remember, the perimeter of a circle is 2 pi r. But we have a semicircle, so this will be half of the circle. But there are 2 of them with this left-hand side and right-hand side semicircle. So it will be 2 semicircles times the half the perimeter of the circle plus these 2 lengths for the straight line. Then we substitute. When we substitute, remember we said our radius now will be 46,26 plus 5 meters plus these 2 lengths, 84,39 times 2. The perimeter of the fence, therefore, will be 490,897 meters. That will be the perimeter of the fence, which is 5 meters away from the outer track. Now let's answer the question. He said, the salesperson said we will need more than 490 meters of fencing. So from what we've calculated, we can safely say he was correct in saying that, because truly we need more than 490 meters of fencing. He pays 120 Rand 45 for running meter for the fencing. Calculate the total cost for the fence. Remember, we need 490,897 meters. And each meter is 120 Rand 45. So to get the total cost, we'll have to multiply the total perimeter of the fence times the cost. Then that gives us 490,897 times the cost per meter. All in all, it gives us 59,128 and 54. So 59,000 rands, 128, 54 will be the cost of the perimeter fence around the track. Then we come to our last activity for the day. Calculate the amount of material that is needed to make a tent, and the tent is in the form of a triangular prism. The ground cloth is attached to the structure of the tent. So meaning we have the ground floor, which is the base, and we have the two sides that are rectangular, and we also have the other two sides that are triangular. So the surface area, you are given there the formula for surface area, the two sides, which are length times the slant height. Then we also have the length times the breadth. Then you have the area of these two triangles, which is base times perpendicular height. So let's use this formula to substitute the given values. What is the length? In this case, our length is 2,5. Length is 2,45. This is the length. What is the slant height? That slant height, I'll just say SL, is 1,737. The length we've mentioned. What is the breadth? The breadth is 1,75. What is the base? The base is the same as the breadth. This one. The same as the breadth. The perpendicular height. The height from this point to this. The height will be 1,5. Then let's substitute. When we substitute, there we have it, our length and our slant height. Our length and our breadth. Our base and our height. Then when we punch that in our calculator, we'll have our surface area being 15,4238 square meters. So the amount of material that will be needed to make the tent will be 15,4238 square meters. That will be the amount of material needed. Learners, that's it for today. We'll take a look at the question that is displayed there, and let's attempt to do this question as homework. The question reads, during winter, many children develop coughs. Cough syrups are sold in bottles packed in rectangular prism-shaped boxes. Children are given cough syrup using a cylindrical measuring cup. The diagrams below show the bottle, the box, and the measuring cup. So we have the bottle, the box, which is used to package the bottle, and the measuring cup that is used to give the children medicine. So calculate in cubic centimeters, in square centimeters. Please note, it says in square centimeters, but you are given your measurements in millimeters. Some of the measurements are in millimeters, but you are asked to give your total surface area of the cough syrup box in square centimeters. The trick is to change your millimeters into centimeters before you do any calculations. Also calculate in centimeters the height of the medicine measuring cup. So you are looking for this H here. You are asked to calculate this H here in centimeters. If the diameter is 2,52 centimeters and the volume is 10 milliliters. It goes back again to our previous knowledge. How do you change your millimeters to cubic centimeters? Remember, 1 milliliter is equals to 1 cubic centimeters. So you will be able to change the volume of that measuring cup into cubic centimeters using the capacity of 10 millimeters. That's where the trick is. I hope you'll be able to do that with your colleagues. Good day, learners. We meet in our next lesson. But before we meet, let's just summarize what we looked at. We looked at the volume as the amount of space occupied by a three-dimensional object. We say it is three-dimensional because it has three dimensions: the length, the width, and the height. Area is the amount of space occupied by a two-dimensional object. It has two dimensions: your side by side, or your length by your width, or your radius by your radius. Surface area is the total sum of external areas of all exposed surfaces of a 3D object. A 3D object is made up of faces of different 2D shapes. I gave an example of a triangular prism. It has got two triangular faces and it has got three rectangular faces. We have a cylinder. It has got two faces that are circular in form. It has a curved surface that is rectangular in form. Then the volume is the amount of space occupied by a 3D object. Like we talked about the volume of a cube, the volume of a cylinder, the volume of something that can be occupied inside that shape. Then the capacity is the amount of space inside a 3D object. And we said capacity is usually related to liquids, and it's measured in milliliters, liters, kiloliters, right? That's it for today. We meet again in our next lesson, on which we'll look at scales, we'll look at maps, and we'll also look at flow plans. Right. Thank you, learners. Meet you next time.